In 10 minutes or less, I'll introduce you to the joint tool and the basics of using it in Autodesk Inventor. Now, so far we've been making parts, and we've just been making parts all by themselves. Wouldn't it be interesting, though, to be able to put parts together and create an assembly of parts? Well, the good news is Autodesk Inventor is a very friendly tool when it comes to putting parts together. So we're going to just start with two simple 3/4 inch wood cubes, our favorite simple parts from Inventor. And what I've done is I've drawn some points on the face of each of my cubes. And the reason I did that is because the Inventor joint tool will actually allow us to use strategic points like these to connect parts together into an assembly using what's called the joint tool in an assembly. So let's say I want to glue these parts together. They're wood. We're going to use glue to put them together. I want these two faces to go together. In reality, I put some glue on them, join them together, and after about 5 minutes, voila, they are glued together. Well, in Inventor, we don't have glue. We have virtual glue, though, and we have the virtual glue again through the joint tool in Inventor. The reason I put these points on here is because Inventor wants us to pick 2 points, one on the origin and one on the destination, to become completely joined together forever. Well, let's say I want the center point of this face to go to the center point of this face. Well, when I join them together, it takes those 2 points, aligns them, and then allows me to do a couple of things. I could make it a rigid joint, meaning I can't move these parts relative to each other. I could make it a rotational joint so that those 2 points in the center of the faces stick together, but they rotate. I could make it cylindrical or slider. A slider, cylindrical, allows it to rotate and move in and out, but those 2 points would still be aligned on the same axis. So the joint tool, again, takes 2 reference points, sticks them together, and then we tell Inventor how to deal with it. So let's take a look at making a joint. So I've created a new part file here in Inventor. It's a cube. It's a 3/4 inch cube. I can come over here and I can expand the extrusion that I used to make the cube. I can right click and edit the sketch over here, and I can see that I made a 3/4 inch, well, it's a square. The reason being, let's show some constraints. I put an equal constraint. The equal constraint already came in because I used a rectangle for the opposite sides, but the adjacent sides I created an equal constraint. So just one dimensional constraint gives me a fully constrained sketch, as I see down here with fully constrained. Awesome, we love geometric constraints. However, this is a single cube. I want to put several cubes together. In fact, I want to put 3 cubes together, and I'm going to do that like this. I'm going to go up to the File tab here in Inventor. I'm going to hover over New, and I'm going to choose a new assembly. I have saved this part file. The part file must be saved to be able to make an assembly using the part. So I come up here to Assembly. It's a new type of file. It is no longer an IPT file. It is a file, save as, I will show you, an IAM file. Inventor Assembly M file. No idea, but IAM is the extension for this. And that's how you'll be able to differentiate between a part file and an assembly file. I am going to save it as cubes.iam. Now the first thing we have to do is we have to bring in the parts that we want to create an assembly of. So I'm going to come up here to Place, and if we hover over that, it tells us, hey, go ahead and specify 1 or more files to place as a component in an assembly. I can actually bring another assembly into this assembly, but that's pretty complicated. Let's just stick with parts at this point. So I am going to place a component. Brings up a file browser for me to look for my parts. I want to use my cube.ipt part. I'm going to click Open. And it's going to allow me to now start placing parts. I'm going to zoom out a little bit. I'm going to place a cube by left clicking. That's my first one, second one, third one, and what the heck, let's put in a fourth. Let's get a little crazy today. So I have 4 cubes in my assembly now. The first thing I need to do is I need to pick one of these cubes to be the anchor, because right now I am left clicking and dragging. I can move all of these cubes. None of them have any kind of fixed position in space. Well, I need one of them to become my grounded or anchor part. So I'm going to right click on this guy here. I am going to choose grounded from the context menu that pops up. And now when I hover over that, you can see my little mouse icon is different than this one. It has a little grounded icon symbol that shows up. And if I left click and drag, it doesn't go anywhere. It's now grounded. That's my anchor. And that's what we want. We always want one part to be our anchor. The other parts now will come and join with that anchor. And because they become joined to the anchor, if we make rigid joints, meaning they can't move at all, they'll all be grounded essentially because they're glued to a fixed part to start. So that's the point of grounding a part. And we'll unground it later and I'll show you exactly what that means. But let's come up here now and create a joint. And you can hover over the joint tool and it'll pop up and it'll show you a little bit of help. And a joint fully defines the range of motion, placement, and behavior of a component. And these relationships that we're going to apply will tell the part where to go relative to another part. So these are all going to kind of, it's like a whisper down the lane of joints. The first part's grounded, the rest all come together to join that. So let's make a joint. Click on the joint tool, it comes up. I generally allow automatic to be the joint type that it creates to start. A gap would allow us to set an offset so that if we want them to be joined and locked in place but not stuck right next to each other, we can do that. And then our connections and our alignments over here will define exactly how the joint plays out. So the first thing I'm going to do is I'm going to pick. Down here it says place origin on first component. Well, the first component origin is what's going to move. So this is the part that's moving to join to the second part. Well, I'm going to pick on this face, and you can see, look, all these little green dots tell us the reference points that we're allowed to use for our alignment. Well, I am going to use the center of this face. That's my origin. Then I'm going to join that to the center of this face. And you see a rigid connection is formed, and the two parts glue together, with those points of reference being the alignment points. If I'm happy with it, click OK, and I'm good. The next thing I'm going to do is I am going to now use an edge to show you how that works. And what I want is I want a cube to come off of the top cube here, off to the right a little bit. So it'll be parallel to the x-axis offset. The way I'm going to do that now is I'm going to come up to joint, and I'm going to choose. Now I'm going to orbit around, because it's always the part that's moving. I want this face, and watch what happens. When I pick a face edge, I can pick the plane that I want the mate to be, the joint to occur from, to be parallel, or I can actually pick it to be parallel to the axis. So I can either parallel to the face or parallel to the axis. Parallel to the axis is good for rotational joints. This, though, because I'm going to glue two faces together, I am going to use parallel to the face, but it's this edge I'm going to use. And you got to be careful about that little circle that gives you a preview. It'll tell you which plane you're going to use. So I want that to come down now to this edge over here. And you'll see that right now, the two faces are pointing opposite directions. Well, I can also make it so that the faces point in parallel directions. Actually, the cube became consumed by the other. I can also flip it. So now this is a better view, I think. You can see that the edge point was used for alignment, but now my two faces point the same way. We call that a flush connection. This would be a mate where the two faces go together. This would be a flush where the two faces both are sharing the same plane. So I want them to be a mate, but I also want them to rotate so that they're joined. Click OK and apply. So now I have three cubes together. One last cube. Let's take this guy up here and we're going to use a corner. The corner I'm going to use is going to be this corner with a plane parallel to this face is going to go to this corner over here with a plane parallel to that face. I need to change my rotation. And you see sometimes that the joints don't behave exactly as we want. So the better approach to this one would probably be joint. Let's go center of face to center of face, and we're good to go. A rigid joint. So there you go, an introduction to joints in Autodesk Inventor.